Our first problem says Bickford traveled 3 times as fast as Sean traveled, thus Bickford could travel 270 miles to the reef, and only 3 hours less than took Sean to travel 180 miles to Jane's house. Find the rates and times of both boys. So they're telling us the specific distance that Bickford could travel. Bickford can go 270 miles. They tell us the specific distance of Sean. Sean can go 180 miles. So we know their distances, so there's no need for a picture in this case. We got Bickford and Sean. So we start off with how far they went. Bickford's going 270 miles, and Sean's going 180 miles. Once we've established that we know that information, my next job is to establish the rates and times using variables for all 4 of those ideas. And we're looking for clues in the problem in order to establish that. So Bickford's traveling 3 times as fast as Sean. So Sean's going some speed, Bickford's going 3 times faster than him. So R and 3R represent their speeds. Using the same variable represent both. And they also tell us Bickford's traveling 3 hours less than Sean. Bickford's 3 hours less than Sean. So if Sean's time is unknown t, Bickford's time is 3 less than that, so t minus 3. The only binomial that we have is the t minus 3, so a distributive property on top is necessary. Once I get rates and times and distances all figured out, I simply do rate times time equals distance for each one. So for Bickford, 3RT, 3R times t, and then minus 9R is going to equal 270. For Sean, R times t is equal to 180. And this is kind of what you're expecting to get in any one of these problems. I don't know what R or t equals, but the product of the two is 180. So I'm going to put 180 in place of that RT right there. So the top equation transforms from what it is into 3 times 180 minus 9R equals 270. That gets me 3 times 180 is 540 minus 9R is equal to 270. Move the 540 over, I get negative 9R is equal to negative 270. Divide by 9, we get R is equal to 30. Okay, now once I've established an answer for one of these things, either R or T, whatever I've found, once I know R is equal to 30, I come back to the chart to establish what that R represents. So my 2 characters here are Bickford and Sean. We want rates and times of both, so the rate of Bickford is something, the time of Bickford is something, the rate of Sean is something, and the time of Sean is something. So what we found is R, 30 miles an hour, is Sean's rate, so that goes here. Once I know that Sean's rate is 30 miles per hour, I can see Bickford's rate is going to be 3 times 30, so 90 miles per hour. As far as time is concerned, we know rate times time equals distance, so if rate is 30 times what time makes 180, 30 times 6 is 180, so Sean's time is 6 hours, and Bickford's time is 3 hours less, 6 minus 3 is equal to 3 hours. If we wanted to verify our solutions, they're very easy to check. The criteria, we're supposed to have Bickford going 270 miles, 90 times 3 is 270, Sean's going 180, 30 times 6 is 180, correct distances created. Bickford's supposed to be going 3 times faster than Sean, 30 times 3 is 90, 3 hours less, 6 minus 3 is 3. Everything checks out with all the criteria in the problem, so that has to be the right set of answers. Number 2, the solution was 55% alcohol. It came up to the 700 milliliter mark of the beaker. How much alcohol should be evaporated, so the remainder would be 10%. So we have a specific amount of alcohol solution. So we have 700 milliliters of alcohol, which is 55%. We're evaporating alcohol. Evaporation, subtraction. We don't know how much alcohol we're evaporating, but we're evaporating pure alcohol. So this is 55% alcohol. This is pure alcohol, which is 100% alcohol. Anytime you deal with pure, it's either going to be 0 or 100. If the thing that we're evaporating matches the same type of thing as this percentage, then we're going to go with the 100. If it said, for example, if this was 55% salt, we're evaporating water, now all of a sudden it's 0%. So again, make that decision based on the material being evaporated. So this is alcohol, or evaporating alcohol, so 100% alcohol. What we're going to end up with is 10% alcohol solution. And the amount of alcohol solution that's going to be is the total that we started off with minus whatever we evaporate. So 700 minus X goes there. And then once you get the setups set properly, now it's just multiply. So 55 times 700, 38,500 minus 100X equals 10 times 700 minus X, that's going to be 7,000 minus 10X. I would move the 100X to the right, the 7,000 to the left. Both objects change signs, so 100X becomes positive, 7,000 becomes negative. That gives me 31,500 is equal to 90X. So if I get my calculator then, do 31,500 divided by 90. I get the divided by sign this time. 350. So X equals 350. Okay, the last thing we need to do is establish what that answer we're looking for is. So if I take a look, it says how much alcohol should be evaporated. What we're evaporating is right here. And we're evaporating X. We got X equals, so that means the answer we found is what we're looking for. So I'm going to say 350 milliliters should be evaporated. They're not asking for the amount left over, they just want to know how much needs to be evaporated. Looking for X, we found X, that's the answer. Number 3, reds vary directly as yellows and inversely as greens squared. I think most of us prefer to do the equal ratio technique on this, so I'll do it that way. Reds varied, so that's R sub 1 over R sub 2 equals fraction bar. It says directly as yellows. That means that yellow's on top, yellow's on bottom, and directly means the subscripts match. So 1 on top, 1 on bottom. And then it says inversely as greens squared. So green squared on top, green squared on bottom. And it inversely means that we're going to invert the subscripts. So subscript 1 goes down, subscript 2 goes up. Be careful when there's squares and subscripts that you make a determination between the two. So greens are being squared, both greens are squared. Subscript 1 on the bottom, subscript 2 on the top. So my first red, first yellow, first green squared, second red, second yellow, second green squared. That's the setup. Once I've established the setup, now I'm going to create a proportion with specific known values. So 600 reds, 30 yellows, 15 greens. That's first number of reds, first number of yellows, and first number of greens. So 600 first red, 30 first yellow, and 15 squared is 225 first green. Alright, so, and I just go ahead and square the greens immediately. Alright, then how many reds? So we don't know the final amount of reds, R sub 2. Went with 80 yellows, so the second yellow is 80. And 200 greens. So if I square 200, it's going to be 4, 0, 0, 0, 0. 2 squared is 4, double the number of zeros, or you can just use a calculator. That creates a proportion that's going to give me the right answer. Rather large numbers involved here, so I'd probably use a calculator. So if I take a look at this product here, and that product there are the two products I need to consider. I'm going to do 30 times 40,000 comes out to 1,200,000 R sub 2. And if I do 600 times 80 times 225, 600 times 80 times 225, that comes out to 10,800,000. So again, just simple cross multiplication. Again, the calculator is doing the calculations for me, so even though they're really large numbers, I'm not having to work that hard to find those numbers. And to get R sub 2, I just have to take the number over here divided by the coefficient. So 10,800,000 divided by 1,200,000 comes out to 9. All right, so expect it to be a similar statement like this, but I'm going to give you probably different numbers here to figure out get that. Number 4, graph. It's a y equals x squared, so it's going to be a parabola. First thing I notice is it's already in descending order, ax squared plus bx plus c order. So my vertex value for x is going to be the opposite of b. B is -2, so the opposite is +2. Over 2a. A is 1, so 2 times 1 is 2. So the vertex value of x is going to be 1. I'm going to create an xy chart here. Put 1 right there in the middle. Pick two numbers smaller than 1, 0 and -1, and two numbers larger than 1, 2 and 3. And I'm going to replace x in this equation with these numbers to establish the y value for each. So if I put -1 in for x, -1 squared is +1. -2 times -1 is going to be +2. +2 makes a total of 5. If I put in 0, 0 squared is 0. -2 times 0 is 0. +2 is going to be 2. If I put 1 in, 1 squared is 1. -2 is -2 plus 2. 1 minus 2 plus 2 is 1. If I put 2 in, 2 squared is 4. -2 times 2 is going to be -4 plus 2. 4 minus 4 is 0 plus 2 is 2. The symmetry is there, so I can be assured that's going to be a 5 already, because I've already figured out the other one. If you wanted to verify that, 3 squared is 9. -2 times 3 is -6 plus 2. 9 minus 6 is 3 plus 2 is 5. There you go. There's the symmetry. So once you get your 5 points, you graph them on the Cartesian coordinate plane. -1, 5. 0, 2. 1, 1. 2, 2. 3, 5. Creates that nice parabolic shape we'd expect. And the only other thing I want to do is include an axis of symmetry. I always put an axis of symmetry in there. And all that is a vertical line that crosses through the vertex. So my vertex is 1, 1. My vertex is here, 1, 1. Vertical line goes right through the vertex. There's my axis of symmetry. And we put axis of symmetry equation, x equals whatever value of x that is. So whatever this number is, that's what goes right there. X equals that number. Identify that on your graph. If you give me the blue without the green, you're going to get half credit, because again, I do want the axis of symmetry. If you get the blue and the axis of symmetry drawn and you don't actually give me the equation of the axis of symmetry, it's still only half credit. So I need all this stuff for full credit. That's only half credit. Even without the green line is half credit. But make sure you give me all the stuff I'm looking for there. Number 5, graphing on a number line. You never want to graph an inequality until you get a regular inequality. So if we have a negated inequality, I want to start there. I want to make that into its proper form. So everything stays the same. Negative absolute value of x, plus 3 and -1. This not less than or equal to means greater than. So again, there's always 3 options: greater than, less than, equal. Whatever it throws out is going to be the other. So 2 things out, 1 thing in, that's what this means. Then I want to get the absolute value expression isolated, so I'm going to move the 3 over here. Minus the absolute value of x is greater than -4. Then I want to change it because I want that to be positive, so absolute value of x and +4. Change both signs. Changing signs in an inequality creates a flip of the inequality symbol. Then we get to our 4 case possibilities. Less than a positive number, the way we handle that is negative number, less than x, less than positive number. If it is equals to, if it said less than or equal to, this would be less than or equal to, less than or equal to. At this point I'm graphing domain set of real numbers, so we're looking for open, closed circle ideas. Obviously with the not equals, we're going to have open circles. Open circle at -4, open circle at +4. X is bigger than -4 going this way, less than 4 going that way. The overlap is going to be in between. If this ended up being greater than 4, it would be x is greater than 4, which would be here, less than -4 there. So if it's less than a positive, it's going to be dot, dot, shade between. If it's greater than a positive, dot, dot, and go opposite directions. So those are the 2 scenarios. I'm probably not going to get you a negative number here. You're going to have to deal with, it's going to be either this graph or the one where it's dot, dot going opposite directions if it says greater than right there. Number 6, find the number that's 3/7 away from 3 1/5 to 5 7/8. So we're starting here, and we're ending here. So to find the number, we're going to do 3 1/5 plus the fractional distance of the distance between those two, which is the ending value minus the starting value. Start plus fraction, end minus start. Okay, I want to subtract these. I'm going to go improper fractions. I think they're easier to work with. 3 1/5 for now. Actually, let's call that 16/5. 3 times 5 is 15 plus 1 is 16. So 16/5 plus 3/7 times. Okay, this is going to be 47/8 minus 15 16/5. Common denominator 40. Times 5 makes 235. Times 8 makes 128. So I get 16/5 plus 3/7 times. All right, 235 minus 128 is 107. So if I multiply these, I'm going to get 321 over 280. And this is 16/5. I need it to be over 280 also. So what I have to ask myself is, what times 5 makes 280? If I don't know that, 280 divided by 5, 56. So times 56 here to make my 280, so times 56 on top. So 16 times 56 on top comes out to 896. So 896, 280 plus 321, 280 if I add them up. 7, 1 carry the 1, 1217, 280 is the right answer. And I'm fine leaving it as an improper fraction. There's nothing wrong with that. Number 7, solve. Okay, when I see a nonlinear system of equations, like x squareds, y squareds, x times a y, letters being multiplied, letters being squared, it creates curves. Whenever I see a nonlinear system, the first thing I do is ask myself, are the variable types the same? In which case they are. So x squared, y squared, y squared. When the variable types are the same, elimination works, and it should be used as easier. So, if I add the equations immediately, y squared minus y squared cancels. 1 plus 3 makes 4x squared. Cancel the y squareds equals 36. That means that x squared is equal to 9 if I divide both sides by 4. That means x equals plus or minus 3. Plus or minus is required. If you forget that plus or minus, you're going to leave off a bunch of answers. So make sure you get all the answers, positive 3 and negative 3. Wants to know what x equals. X equals either positive 3 or x equals negative 3. I take one of the two equations I started off with. I prefer the top one. Everything's positive in the top one. It says x squared. All right, so whether x is positive 3 or negative 3, notice x squared equals 9. So these are going to make the same equation. So whether x is 3 or negative 3, when I square it, x squared is 9. So that's going to become 9 plus y squared is 25, which means y squared is equal to 16, which means y is equal to the square root of 16, which again is plus or minus 4. Again, don't forget the plus or minus. Letter squared equals number. Letter equals plus or minus square root of number. Okay. This answer for x led to both of these y answers. This answer for x led to both of these y answers. So my answers are going to be x3, y positive 4, x3, y negative 4, x negative 3, y positive 4, x negative 3, y negative 4. So that's how it's going to work on the test too. Just don't forget the plus minuses. When you forget plus minus, you give me the positive answer. All the negative answers are missing. You lose 3/4 credit. Number 8, system of 3 equations, 3 variables in each one. I would probably, I'm going to get rid of y. So if I add these two equations together, y is easy to get rid of. X plus 2x is 3x. Y minus y cancels. Negative 2z plus z is minus z. And 0 plus 4 is 4. And if I group these two equations together, doubling this one, negative 2y plus 2y will cancel. So 2x plus 4x makes 6x. And then I've got negative 2y plus 2y cancels. 2z minus z makes plus z. And 8 plus 6 is 14. So just like that, I got rid of y twice. In the blue group, I didn't have to do any multiplication. They were ready to go. The red group, I had to double this one, so I doubled everything. 4 plus 2, 2 minus 1, 8 plus 6. and the y is negative 2 and 2 cancel. At this point, my system has only x and z in it, so I'm going to use elimination or substitution with that. And I got lucky in my process that the z's are already ready to go. Great. If it wasn't like that, then again, some multiplication might be necessary. Negative z plus z is going to cancel. So 3x plus 6x is 9x. Negative and positive z cancels. 14 and 4 make 18. So x equals 2. Once I know what x equals, if I go back to the red equation, 6x is going to be 12. 2 times 6, plus z we don't know yet is equal to 14. Move the 12 over here, we're going to get z is equal to 2. So I get x equals 2, z equals 2. I go back to any equation up here, I'm going to go to this one. I already know that x and z, what they are. So x equals 2, y we don't know yet. Z is 2, minus 2 times 2 is going to be minus 4 is equal to 0. That ends up being y minus 2 is equal to 0, so y is equal to 2. So x, y, and z all equal 2. X, y, z order is going to be 2, 2, 2. No doubt on the order there because they're all the same. If they were different, make sure x goes first, y goes second, z goes last in your order triple. Number 9. We have a complex fraction inside a fraction. So first thing I want to do is I want to take this out, fix it, and then put it back in. So what I have here, the original problem is j on top, jm squared minus on bottom. And what I want to do is I want to create a better structure for this right there. So that's my first task. So I take that out, 5 over 2 plus 3 over jm. The only problem is the 3 over jm, so I'm going to do times jm times jm times jm. What that creates on top is just 5jm. What creates here is just 2jm. And what it creates here, the jm's cancel, is going to be plus 3. So this expression here is equivalent to what I have boxed in there. So I'm going to take this and put it back into the original problem. So I've got 5jm over 2jm plus 3. That's in the same position that is, and they're equivalent. This is easier, this is simpler. The structure of my current problem, the entire problem now is the same structure this was over here. This is not a fraction, this is not a fraction, but this is. This denominator is going to be the fix. So what I need to do is multiply times 2jm plus 3 times 2jm plus 3 and times 2jm plus 3. So on top, distributive property. J times 2jm is going to be 2j squared m. J times 3 is plus 3j. Down here, distributive property here also, jm squared times 2jm is going to be 2j squared m cubed. 3 times jm squared is going to be plus 3jm squared. And then here, no distributive property necessary because 2jm plus 3 on top and 2jm plus 3 on bottom cancel, leaving with minus 5jm. That is the correct answer. I'm not going to count that wrong. Everything's great about that. One extra added feature on this specific problem, every single term contains the letter j in it. If you notice that and want to reduce it, take a j out of every term. So you're going to get 2jm plus 3 on top. You're going to get 2jm cubed plus 3m squared minus 5m. That's a better answer, but again, that's full credit if you want. Don't even worry about reducing it. Just get me to that point correctly and all is well. So most people mess up on this one term here because they didn't go through this process. So do take that out, fix it, put it back in, and this term tends to be the right term at that point. Number 10, simplify. Okay, and I noticed imaginary numbers in the denominator, and I also noticed an I squared, which we don't usually have I squareds in this structure. So first thing I'm going to do is make that better. So 5 plus 2i is perfectly fine the way it is. I squared is negative 1 times 3 makes negative 3 minus 4i. That's a better structure than that because everything's now either a real number or just an I to the first power. And the problem, the reason it's not simplified is we do not want i's in the denominator. So the complex conjugate of negative 3 minus 4i is negative 3 plus 4i. Same first object, opposite sign on the second object. And multiply the top also by negative 3 plus 4i. Then it's just FOIL on top. First times first is negative 15. Outside times outside is positive 20i. Inside times inside makes negative 6i. Last times last makes positive 8i squared. And I recommend just multiplying it straight out. Don't worry about the fact that I squared is -1. Just get what you get. So opposite sign's negative, same sign positive, opposite sign's negative, same sign positive. So get what signs you get on every single term based on the facts that the signs are what they are. All right. On the bottom, I've got FOIL also, so -3 times -3 makes +9. Now on the bottom, you do have a shortcut because the outside product of -12i and the inside product of +12i are always opposite. So if you want to avoid the O and the I part of FOIL, you're allowed to on that one. If I look at last times last, -4i times +4i makes -16i squared. So once again, get what you get. Two negatives make a positive, opposite signs make a negative. Let the signs be what they are for the products before you start worrying about the fact that I squared is -1. Okay? Real number, I to the first, I to the first, I squared. This has to be fixed. Real number, I squared, this has to be fixed. So all these are fine. Positive 8i squared is going to be -8. -16i squared is going to be +16. So now if I combine my real numbers, -8 minus 15 is -23. Add the imaginaries, 20i minus 6i is +14i. Same sign add, bigger number negative. Same sign, opposite sign subtract, bigger number positive. You get what you get. On the bottom, same sign, 9 plus 16 is 25. And the final step on a complex number problem, real first, imaginary second, split them apart into two separate pieces. So -23 25ths plus 14 25ths I. I'm not going to count this wrong, but this is good practice. Just get in the habit of anytime you see imaginary complex numbers, real number, then imaginary number, separate them from each other. Number 11, we have two vectors. Let me use some different colors here to help reinforce some stuff. So we'll put this vector here as red, and we'll put the other vector as blue. So let's start with the red vector. When you see a slanted vector, you have to concern yourself with what quadrant it's in. So the red vector is going into the first quadrant. The angle in the picture is always alpha, and theta that we're looking for is always equal to some version of alpha. So in the first quadrant, theta and alpha are the same thing. If you don't remember those facts, they're on your formula sheet under the conversion to polar form. Grab the formula sheet real quick and highlight where that's at. See if I can get that really close. It's right here. All right, so looking at the red vector, the magnitude of the vector is what it is. The angle is alpha, but we want theta, and in the first quadrant, alpha and theta are the same thing, so 45 degrees. So no weirdness on the red vector. Looking at the blue vector, its magnitude 7, its angle is 60 degrees, which again is alpha for that. In the second quadrant, because that's where it's at, is the second quadrant, theta is equal to 180 minus alpha. So in this case, the magnitude of vector 2 is 7. Its angle is not 60 degrees, it's 180 minus 60, so it's 120 degrees. If you get the wrong angle, you're going to be in the wrong quadrant, and it's going to get you the wrong answer. If I put 60 right there, that's what 7 angle 60 looks like. It's in the first quadrant instead of the second quadrant. So we're looking for the second quadrant. We're looking for theta. Theta is this angle here. 120 degrees this direction leaves you 60 degrees short of 180. So again, be very careful. Establish a quadrant. Get a rule for theta based on the alpha in the picture. Once you get both vectors written in proper form, now we want to get them both into rectangular form. So I'm going to do 5 cosine of 45, 5 sine of 45 to get the horizontal and vertical components of the red vector. So the red vector is 3.54i plus 3.54j. Looking at the blue vector, I'm going to do 7 cosine of 120 and 7 sine of 120. That gets me negative 3.5i and positive 6.06j. Right? So, once I get the two vectors in component form, I add them together or subtract depending on sign. These signs are different. I subtract. I'm going to get positive 0.04 I. And if I add these, they're both positive, I'm going to get 9.60j. So that's the answer in rectangular form. The final step I want to do is get the polar form. So I need to go back to polar form. So the magnitude is going to be the square root of 0.04 squared plus 9.60 squared. My calculator knows the answer to that. Square root 0.04 squared plus 9.60 squared in parentheses equals 9.60. The reason it's the same number is because that's so small, it has almost no bearing on it. So 9.60. Alpha is going to be the inverse tangent of 9.60 divided by 0.04. Inverse tangent of 9.60 divided by 0.04 comes out to 89.76 degrees. And then finally, theta, we have to establish a quadrant. So this is positive, this is positive. That takes me to the right and up. If I go right and up, I'm in the first quadrant again. First quadrant, theta equals alpha. So theta we're looking for is going to equal alpha, 89.76 degrees. So magnitude 9.60, angle 89.76 degrees. That is the resultant vector for those two forces. Number 12, simplify. The first thing we're supposed to do in these problems is break each of these up so it's just a numerator and denominator. So 5 times the square root of 3 is the numerator, square root of 11 is the denominator. Neither 3 nor 11 can be broken down to anything simpler, so they're fine the way they are. The second one says plus, and I'm going to leave myself a little space here, plus, I'm going to put 7 times the square root of 11 on top, square root of 3 on the bottom. And then I've got minus 2 times the square root of 132. Again, leaving myself a little bit of space for the minus sign, and I'm going to put a little space in front of the 2. And looking at 132, 4 times 33, and then 4 is 2 times 2, and 33 is 3 times 11. So 2 times 2 times 3 times 11 is the prime factorization of that number. So that's priority 1. Rewrite the fractional one so it's top over bottom, top over bottom. Rewrite the single one doing a factor tree into a prime factorization. And then we're looking to simplify each of these objects. So for the fraction ones, I don't want radicals in the denominator, so multiply by the square root of 11 on top and bottom. That gets me for the blue term here, 5 times the square root of 33 on top. Square root of 11 times itself makes 11. The second one, multiply top and bottom by the square root of 3. So for the red term, I'm going to get 7 times the square root of 33 on top. Square root of 3 times itself on the bottom makes 3. For the green one, pair of 2's, get to pull 1, 2 out. The 3 and 11 don't get to come out. So for the green one, 2 times 2 came out, that's 4. 3 times 11 stayed in, that's 33. I'm going to put that over 1. So fix each object. At this point, every radical should be the same. If they aren't, then that means that you probably didn't see that came out, or maybe it's a situation like I had recently where maybe these are simplifiable. So maybe it's 8 instead of 3, so it's 2 times the square root of 2. That kind of stuff will be happening. But these all should be the same radical at this point. So what's left to do then is get a common denominator for everything, which is 33. And then do whatever multiplication is necessary to make that happen. So times 3 makes 33, so times 3 on top. Times 11, so times 11. Times 33, so times 33. So the blue one, 5 times 3 makes 15 times the square root of 33. Red one, 11 times 7 makes plus 77 times the square root of 33. And for the green one, 4 times 33 is 132 times the square root of 33. So to get the final answer, we simply add and subtract the top stuff. 15 plus 77 is 92, minus 132 is negative 40. We're looking for an answer sort of like that on these problems. One number times the square root over another number every single time. This might reduce, it doesn't this time, but look to reduce that if possible. Leave the radical as is when you're doing that. So if you look at the fraction outside, if it reduces, you should. Number 13. We've got this object, we've got this object, this object, and this object. So we've got 4 objects all together. The first 2 objects have radicals with negatives involved. The second 2 objects have i's to power. So we'll deal with the radicals first. First thing I always do on an imaginary problem like this, if I see radicals in the problem, if there's any minuses in the radicals, I take out the i's. This times this times this, so it's all still together. This times this times this. A minus in a radical makes an I. Minus in a radical makes an I. Once I take the i's out, the radicals become positive. Everything's fine with that. The second one, 3 is already outside. I'm going to take an I out for the negative, and the square root of 9 is left there. Then I've got minus 6 times the I to the 5th, and I've got plus 3I squared. I know what I to the 5th and I squared are. I don't want to deal with that yet. I'm going to fix all the other stuff first. Okay, right here. 5 times 5, square root of 5 times square root of 5 makes 5. The minus sign makes it negative. I times I is I squared. Again, let the signs be what they are. There's a single minus sign. Everything else is positive. So square root of square root make 5. I and I make I squared. I know I squared is negative 1. Don't worry about that yet. Just get the sign what it is. Square root of 9 is 3 times 3i makes 9i. Once again, don't worry about any signs. Everything's positive, so it's positive. And I've got minus 6i to the 5th. And I've got plus 3i squared. Okay. When I get to the point where there's no more radicals, just a bunch of numbers and I stuff, the only i's I want is I to the first power. So this is ready to go. This is too big, too big, too big. There's no real numbers in this at this point. So this is the part now where I want to go to the I squared and I to the first power and all that stuff. So I to the first is I to the second is negative 1, I to the third is negative I to the fourth is positive 1. So, and then of course I to the fifth repeats the pattern. So, negative 5i squared is just negative 5 times negative 1. 9i again is behaving itself, it gets to be 9i. 6i to the fifth is 6i to the first. And 3i squared is 3 times negative 1. At this point, if I simplify each object as much as I possibly can, negative 5 and negative 1 make positive 5. Plus 9i minus 6i minus 3. And then it's just a matter of getting the real number and the imaginary number. Reals, 5 minus 3 makes 2. Imaginaries make plus 3i. Opposite sign subtract, 5 is bigger positive. Opposite sign subtract, 9 is bigger positive. Okay, that's the process. If you want to cut corners, that's up to you. Just make sure that you don't cut so many corners you get the wrong answer. If you get the right answer, cutting corners is fine. If you're not getting the right answer, that's how you don't cut corners. Every single step shown there. Number 14, find f. F right there. First thing I notice is parentheses, so a over b plus c equals dE over f plus dg. Distribute d times this, d times this. D's in the numerator, so it multiplies only by the numerator. Second thing, once parentheses are gone, we want to get rid of fractions. Least common denominator of the two fractions present is f times b plus c. If I distribute f times b plus c times a over b plus c cancel b plus c, leave me with af. When I multiply f over b plus c times dE over f, f cancels f, leaving me with dE times b plus c. And when I multiply f times b plus c times dg, nothing cancels, so I'm going to get dgf times b plus c. Once I get to that point, one more distributive property is going to get rid of the parentheses. I'm going to get AF equals BDE plus CDE plus BDFG plus CDFG. Okay. That gets me all this, and at this point, what I want to do is find f. So at this point, what I care about is what I'm trying to find. Everything containing f has to go to one side. So I'm going to move that BDFG and CDFG over to the left. So AF minus BDFG minus CDFG is equal to BDE plus CDE. And by moving that over to the left, f is in this term, f is in this term, f is in this term. Common factor of f can be pulled out. We factor that out. A minus BDG minus CDG is equal to, this side stays as is, BDE plus CDE. And our final step in these problems is always to divide by this stuff here. So dividing both sides by A minus BDG minus CDG. So on this side, those cancel, leaving with f equals. And then on this other side, I just get the answer, which is that thing. And our final problem, number 15, convert 600 cubic feet per minute to cubic inches per second. So 600 feet cubed per minute, and we want to go to cubic inches per second. So we've got two conversions going on here, cubic feet to cubic inches. I know 1 foot is equal to 12 inches. That's the fact. That doesn't say cubic, that doesn't say cubic. So when I multiply, I want to put feet in the denominator, inches in the numerator. The fact is one of these equals 12 of those, so 1 and 12. This right here says cubic feet, this doesn't, so I have to cube this to get the cubic feet to happen. So now this is cubic feet, it's also cubic inches, 12 cubed and 1 cubed. This cubic foot cancels this cubic foot, leaving me with cubic inches, which is what I'm looking for. On the bottom, I want to change seconds, or minutes to seconds. I know 1 minute is equal to 60 seconds. This is minutes to the first power, this is seconds to the first power, that's what we're trying to change to. So when I do this conversion, minutes on top, seconds in the denominator, and I know 1 minute is equal to 60 seconds, this unit matches that unit exactly, so we're ready to go with that. No cubing necessary. So to get my answer, I simply have to do 600 times 12 cubed divided by 60. Whatever that comes out to is going to be the answer. So 600 times 12 to the third power divided by 60 comes out to 17,280. And the unit is going to be cubic inches on top per second on the bottom.